Welcome to our latest video on the topic of making insoluble salts from precipitation reactions. This video is suitable for GCSE students. By the end of this video lesson, you should be able to explain how clean, dry samples of insoluble salts can be prepared by adding solutions of two soluble salts together. You should also understand that insoluble salts are called precipitates and that precipitation reactions form the basis of many chemical tests. And finally, you should be able to describe precipitation reactions using word, chemical and ionic equations. In our previous video lessons, we've seen that we can make soluble salts by a variety of different methods. For example, we can react an acid and a base together, either an insoluble base or a soluble base called an alkali. And when we react these together, we form a salt and water. We've also seen that we can react acids and metals together and form salts and hydrogen, providing that the metal is more reactive than hydrogen and therefore can displace hydrogen from the acid. Now we've also seen that acids react with metal carbonates to form a salt, carbon dioxide and water. Now in all these methods, we've produced soluble salts, and to obtain crystals of the soluble salts, we've evaporated off the water by heating the solution of the salt in an evaporating basin. To obtain large crystals, we've evaporated some of the water off, usually about 2/3 of the water that's present, and left the remaining water to evaporate slowly in the evaporating basin by placing it on a windowsill. Now another method of making salts is by precipitation reactions. And in this method, two solutions of soluble salts are added together to form an insoluble salt called a precipitate. And the insoluble salt or precipitate can then be filtered, washed and dried. So for example, lead nitrate is a soluble salt. So is potassium iodide. Now if we mix solutions of lead nitrate and potassium iodide, we form lead iodide, which is insoluble, our precipitate, along with potassium nitrate, another soluble salt. Now in the WJC syllabus, we're not expecting you to remember lots of rules on solubility. However, it is useful to know that all nitrates are soluble, and all sodium and potassium compounds are soluble. Now it's useful to know this because when you look at this equation, if you know that all nitrates are soluble and all potassium compounds are soluble, you then can see that it's obvious that lead iodide is the precipitate that forms. So now let's look at this reaction close up. So you can see we're adding potassium iodide here to lead nitrate, and as soon as we add the potassium iodide to lead nitrate, we form an insoluble solid which is yellow. This is our precipitate, and this precipitate is lead iodide. Now my other product, potassium nitrate, is soluble. Now this slide summarizes what takes place in a precipitation reaction. Now in a precipitation reaction, two solutions are added together to form an insoluble solid. And in this second example, we have silver nitrate and sodium chromate. Both are soluble salts. And when we mix them together, we form silver chromate, which is an insoluble salt, and sodium nitrate, a soluble salt. And the silver chromate is classed as a precipitate. This is our insoluble solid, our insoluble salt. And the reaction that takes place is a precipitation reaction. Now to obtain a clean, dry sample of our insoluble solid, we would use the following method. First of all, we would mix two soluble salts together, two solutions together. A precipitation reaction would take place and we would produce our insoluble salt, the precipitate, and a soluble salt. Now the next step would be to filter the mixture, and we do this to separate the insoluble salt from the soluble salt. And we would then obtain our precipitate, which would be on the filter paper, and our soluble salt would pass through the filter funnel and would be our filtrate. Now after you've filtered the mixture, you're left with your precipitate, your insoluble salt, on the filter paper. So your next step is to wash the precipitate several times using deionized water, because you're trying to produce a clean, dry sample of your insoluble salt. Now once you've washed your precipitate, the usual method is to scrape the solid off the filter paper and put it on a dish, and then the dish is put in an oven where you can dry the precipitate. After you complete this, you'll be left with a clean, dry sample of the insoluble salt. Now, precipitation reactions are often used in chemical tests. For example, to test for a chloride, we use silver nitrate. Now, if you add silver nitrate, which is a soluble salt, to any chloride, so for example, we could add it to seawater, which is sodium chloride solution, we form a white insoluble solid, silver chloride, which is called a precipitate. Now, the white precipitate indicates that we must have had a chloride present, and therefore silver nitrate can be used as a chemical test for any chloride. Now, this reaction can be described with a chemical equation. So the chemical formula of sodium chloride is NaCl. The chemical formula of silver nitrate is AgNO3. And when they're added together, they form sodium nitrate, a soluble salt, NaNO3, and the insoluble salt, silver chloride, AgCl. And it's the silver chloride which is our precipitate. You'll remember that all nitrates are soluble and all sodium compounds are soluble. So therefore, of the two products, it's the silver chloride which is our precipitate. And this precipitate has a characteristic white colour. And that's because silver chloride is white, and a white precipitate is the observation you get when you test any chloride with silver nitrate. Now, another test that relies on precipitation reactions is the test for a sulfate. Now, if we add barium chloride or barium nitrate to any sulfate, we form the insoluble solid, the insoluble salt, barium sulfate. And this is characterized by a white precipitate. And this precipitate is quite milky in appearance and is very thick. So the presence of a thick white precipitate indicates that we must have a sulfate present. So for example, if we added barium chloride to magnesium sulfate, you see we get the milky white precipitate of barium sulfate, and we can describe this reaction with a chemical equation. So the chemical equation would be as follows. BaCl2 is the chemical formula for barium chloride. Magnesium sulfate has the chemical formula MgSO4, and we produce the precipitate, barium sulfate, BaSO4, and magnesium chloride, MgCl2. Chemical tests are therefore a major use of precipitation reactions, because we can identify ions such as the chloride ion and the sulfate ion by adding soluble salts to solutions of these ions and identifying the presence of these ions by the precipitates that form. Now, it's not just chloride ions and sulfate ions that can be identified by precipitation reactions. We can also identify the presence of bromide ions and iodide ions if we add silver nitrate to solutions of these ions. Now, adding silver nitrate to any bromide will produce a cream precipitate because you form silver bromide, which is a cream insoluble solid. And if you have any iodide present and you add silver nitrate, you form a yellow precipitate. And this yellow precipitate is quite pale in appearance, and it's due to the formation of silver iodide, which has a chemical formula AgI. Now, when describing precipitation reactions, we could use word equations or chemical equations. However, there is another way we can describe these reactions, and that's via ionic equations. Now, in an ionic equation, we write down the formula of the precipitate that forms. So, for example, if we have the white precipitate silver chloride, we write down the formula for silver chloride, AgCl. We put an arrow pointing to the silver chloride, HeCl. And then on the left-hand side, we write down the ions that form this precipitate. So Ag plus ions would react with Cl minus ions to form the precipitate AgCl. Now, in the case of the cream precipitate silver bromide forming, the ionic equation for this would be Ag plus Br minus forms AgBr. And for the yellow precipitate of silver iodide, the ionic equation would be Ag plus I minus forms AgI. Now, we don't include any other ions in these ionic equations because they don't take part in the main reaction. We call these spectator ions. For things like nitrate ions or maybe sodium ions, if you're adding sodium chloride to silver nitrate, would not be included in ionic equations. Now, in writing these, we just need to write down the ions that react together to form the precipitate. These are the ions that take part in the main chemical reaction, the precipitation reactions, and we class all other ions as spectator ions because they don't react together to form the precipitate. Now, when writing ionic equations, it's useful to include the state symbols. So you'll notice that for Ag plus here, we've also written AQ in brackets, and that stands for aqueous, and that shows that the Ag plus ions are dissolved. They're part of a soluble compound, a soluble salt. Now, the halide ions also have AQ in brackets after them. So you'll see Cl minus, Br minus and I minus are followed by AQ in brackets. This is also because these are aqueous solutions. The ions are dissolved in water. The compounds containing chloride, bromide and iodide ions are soluble in water, and we have solutions. Now, in the ionic equation, we show that we form an insoluble solid or precipitate using the state symbol S. So you'll notice that AgCl, AgBr and AgI all have the state symbol S. The S stands for solid, and this shows anyone looking at the equation that we form an insoluble solid called a precipitate as part of this reaction. So now let's test your understanding of this with some practice questions. Here's your first practice question. Read through the question, pause the video, have a go at it, and then we'll go through the answers. So now let's go for the answers to question 1. So the question is saying that lead iodide is made by mixing a solution of lead ions with a solution containing iodide ions. And it's asking you to draw a ring around the name given to this type of reaction. So this is worth 1 mark, and the answer is a precipitation reaction. And for part 2, it's asking you to tick the method used to separate the solid lead iodide from the solution, and this is also worth 1 mark, and the answer is filtration. So here's part B. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers to part B. Now in part B we have a table, and the question says use the table to answer the following questions. So in the table it says that all sodium and potassium salts are soluble compounds, all nitrates are soluble, and most chlorides, bromides and iodides are soluble. It also says that insoluble compounds are silver and lead chlorides, bromides and iodides. Now the question says use the table to help you, and it says draw a ring round a soluble compound which contains lead ions. So this would be lead nitrate. 1 mark if you said that. And this is because all nitrates are soluble. And then it says draw a ring round a soluble compound which contains iodide ions. Now this would be sodium iodide, because as the table says all sodium salts are soluble. 1 mark for that. So now have a go at question 2. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers to question 2. So question 2 states that silver nitrate is used as a chemical test for halide ions. So by halide ions we mean chloride ions, bromide ions and iodide ions. And the question is asking you what colour precipitate would you expect if silver nitrate was added to A, potassium iodide and B, sodium bromide. Now if it's added to potassium iodide you would form a yellow precipitate, and this is because you form silver iodide. And if you added silver nitrate to sodium bromide you would form a cream precipitate, that's because silver bromide is cream. And there's 1 mark for each correct colour here. So now have a go at question 3, and there are 4 parts to question 3, A, B, C and D, and A and B are on this slide. So read through the question, pause the video, have a go at it, and then we'll go for the answers to parts A and B, and then we'll look at parts C and D. So now let's go for the answers to 3A and 3B. So question 3 is saying that silver nitrate is added to sodium chloride and a precipitation reaction takes place, and it's asking you for the meaning of the state symbols AQ and S, and there's 2 marks for this. Now AQ means aqueous, i.e. the compound or ions are dissolved in water. 1 mark for that. And the S means solid. So this means that the compound formed is an insoluble solid or precipitate. 1 mark for that. Now for question B, it's asking you to write a word equation to describe the reaction of potassium iodide solution with silver nitrate. So the word equation would be potassium iodide plus silver nitrate forms silver iodide and potassium nitrate. Now if you've written the word equation correctly, there's 1 mark for this. Now in this equation, the silver iodide is our precipitate and potassium nitrate, the other product, is a soluble salt. So now have a go at questions 3C and 3D. So once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So for question 3C, we're asked to write a chemical equation to describe the reaction of potassium iodide with silver nitrate. So to do this, I'm first going to write the word equation. So we have potassium iodide added to silver nitrate, and we're going to form silver iodide, which is going to be our precipitate, and potassium nitrate. And this word equation represents a precipitation reaction that takes place. Now once I've written the word equation, I can now write chemical equations and ionic equations. So to write a chemical equation, I need to replace the words in the word equation with symbols. So for potassium iodide, we have the ions K plus and I minus. And because these have the same charge, they cancel out. So the formula of Potassium iodide is Ki. So I'm going to write Ki in my chemical equation here. And now I need to come up with the formula for silver nitrate. So silver nitrate is made up of Ag plus ions and NO3 1 minus ions. Once again, these have the same charge. So the chemical formula will be AgNO3. So I'm going to write this in now. And the next formula I have to come up with is silver iodide. So silver iodide is Ag plus ions and I minus ions. Once again, the charge is the same, so they cancel out. So the chemical formula of silver iodide is AgI. And the last chemical formula I have to write is potassium nitrate. So we have K plus NO3 1 minus. Once again, the charge is the same, so they cancel out. So the chemical formula is KNO3. So I'm going to write KNO3 in my chemical equation. Now all I need to do is check its balance. So I have one potassium on the left, one on the right, one sodium on the left, one on the right, one nitrogen on the left and right, and 3 oxygens either side. So the chemical equation is balanced. Now, silver iodide is my precipitate. And in part D, I'm asked to write an ionic equation to describe the reaction. So all I have to do is write down the ions that form silver iodide. So the ion for silver is Ag+. The ion for iodide is I-. They're both aqueous because they're soluble salts. And we form the insoluble salt, silver iodide, which is AgI. And I'm putting the state symbol S to show that it's a precipitate. Now it's important to remember that when writing chemical formula, chemical equations or ionic equations, you don't have to learn the ions. They are given to you in a table in the exam paper. So questions C and D are both worth 2 marks each. So if you had the chemical formula right of the reactants on the left hand side of the equation in part C, you get 1 mark. If you had the chemical formula right of all the products on the right hand side, the AgI and the KNO3, you get the 2nd mark. And for part D, if you had the Ag plus and the I minus correct on the left hand side, you get 1 mark. And if you had the AgI correct on the right hand side, you get the 2nd mark. Now, for the Ionic equation, I would not penalise you if you missed out the state symbols here, but many questions will require you to include the state symbols. So now have a go at question 4. So this again is made up of 4 parts, A, B, C and D. Here are parts A and B. So once again, read through question 4, pause the video, have a go at parts A and B, and then we'll go through the answers. So question 4 says that barium chloride is often used as a chemical test for a sulfate, and part A is asking you to use your knowledge from this lesson to say what colour precipitate you think you would form if barium chloride was added to potassium sulfate. Well, the test for a sulfate is to add barium chloride, and if a sulfate is present, you would get a white precipitate. So if you said white precipitate, there's 1 mark. And then you're then asked to write a word equation. So potassium sulfate plus barium chloride would produce barium sulfate and potassium chloride. There's 1 mark for that. Now here are questions 4C and 4D. So once again, read through the questions, pause the video, have a go at them, and then we'll go through the answers. So question 4C is asking you to write a chemical equation to describe the reaction between potassium sulfate and barium chloride. So the first thing I'm going to do is write a word equation to help me. So potassium sulfate and barium chloride will produce barium sulfate, which is our precipitate, and potassium chloride. Now that I've written a word equation, I can have a go at the chemical equation. And all I need to do is replace the words in the word equation with chemical formulae. So to do this, I use the ions that I get from the ions table, which is given to me in any exam paper or any test. So the ion for potassium is K+, the sulfate ion is SO4 2-. So to work out the formula, all I need to do is either swap the charges round, like this, so therefore it would be K2SO4 and we don't bother writing the 1 down, and that would be the formula K2SO4. Or I just say how many K pluses do I need, 1 pluses, to cancel out the 2- charge, and that would be 2. Now to write the formula for barium chloride, I write down the two ions, Ba2+ for barium, Cl- for chloride. Again I swap the charges round and the formula is BaCl2. I can also think of it as how many minus charges in Cl- do I need to cancel out the 2+ charge, 2. Now to write the formula for barium sulfate, I write down the ions Ba2+ and SO4 2-. Now as they're the same, they cancel out, so the chemical formula of barium sulfate is BaSO4. So I'm going to write that down in the chemical equation. Now the last formula I have to work out is potassium chloride, and potassium chloride is made up of K+ ions and Cl- ions. Notice they have the same charge, so they cancel out, so the chemical formula is KCl. So I'm going to write KCl in the equation, and then all I have to do is check it's balanced. So on the left hand side I have 2 potassiums and 1 on the right, so I have to put a 2 in front of the KCl. And if I do that, it's all balanced. I have 2 chlorines on the left, 2 on the right, 2 potassiums on the left, 2 on the right, 1 barium on the left, 1 barium on the right, and 1 sulfur on the left and 1 on the right, and 4 oxygens on either side. Now the precipitate is BaSO4. So if I'm going to write the ionic equation to describe the reaction, all I need to do is write the 2 ions that produce BaSO4 when they react together. So the 2 ions will be Ba2+ and SO4 2-, and the state symbols will be AQ for both of these, and the precipitate that forms is BaSO4, and I indicate that it's a precipitate by using the state symbol S. Now parts C and D are both worth 2 marks each. For the chemical equation, if you had all the chemical formula correct, but it wasn't balanced, you get 1 mark. If you have it balanced, you get the 2nd mark. And then for part D, if you had the left hand side of the equation correct, so in other words you wrote Ba2+ and SO4 2-, you get 1 mark. And if you had the right hand side correct, BaSO4, you get the 2nd mark. I would not penalise anyone for missing out the state symbols here. So that concludes this video lesson. So after watching this video, you should now be able to explain how clean dry samples of insoluble salts can be prepared by adding solutions of 2 soluble salts together. You should understand that insoluble salts are called precipitates and that precipitation reactions form the basis of many chemical tests. And finally, you should be able to describe precipitation reactions using word, chemical and ionic equations. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.